No, it's okay. That had that one word problem.
Yeah, that ain't very straight, that bottom one there.
It's okay. We'll live. All right, so special angles. This morning when I said special angles, they all went, we did something with that. You guys did special what's in geometry?
Special function.
Yes, you did your special right triangles. Yes. I'm impressed you remember.
Hey, you.
Okay, now I'm about to show you why you don't want to have to do this every single time you want to do a trig function with special angles. But yes, whoops, that's not the 30, that's the 60. 30, 60, 90, and 45, 45, 90. Do you guys remember the side lengths that go with them?
One was
Something square root of 3. By the way, they hit this really, really heavy on the ACT. You want to know these days. 30, 60, 90, 1, 2, square root of 3. One's opposite the short side, 2's the hypotenuse, square root of 3. And the other one is 1, 1, square root of 2. Okay? But my point is, I'm going to need you to know what's the sine of 30 degrees. I don't think every time you want the sine of 30 degrees, you want to have to go, draw this triangle out and go opposite over hypotenuse, make sine of 30 degrees 1/2. That's too slow and too troublesome. We need a better way to learn these values. I could ask you what's the cosine of 45 degrees, and you would go, what's adjacent over hypotenuse in this triangle? By the way, how do you know which side is adjacent?
Closest one. They're not hypotenuse.
It's the side, there's two sides that form the angle. It's got to be the one that's not a hypotenuse. So yes. In this case, it'd be 1 over square root of 2, which they will rationalize into square root of 2 over 2. But still, that's slow. We don't want to do that all the time. I doubt most of you visualize those triangles in your head just instantaneously. Well, it turns out you can make a little chart out of them, and there's this amazing pattern to this chart. Well, it's pretty amazing that this works. And it seems like it's not very well known out there in the real world. Most people don't teach it this way, but I have found great success with this. Okay. Our chart has what we call the 5 special angles in it. 0, 30, 45, 60, and 90. And it turns out you could look up sine of 0, sine of 30 in these triangles and figure it all out. Or there's a pattern. See if you see the pattern here. In the sine column, you do square root of 0 over 2. Next one is square root of 1 over 2.
Yeah, I see it.
Square root of 2 over 2. So what's going to be the next one? Square root of 3 over 2. And square root of 4 over 2. Okay, now some of those will simplify and reduce down, which we want to do. For example, what's the square root of 0? 0, and 0 divided by 2 is 0, so that's really just 0. Square root of 1 is really just 1, so that's really a half. Are there any others of those that were simplified? Yeah. Square root of 4 would be 2 over 2, so that one's really 1. So you actually can know 0, 1/2, square root of 2 over 2, square root of 0 over 2 is 1. Gives you the sine value. Now, anybody? Exactly, yeah. Fine, roll it. You all know that, but yes. Did Thomas tell you that? So. Okay. Yes, the cosines go in reverse. So you start the 0 down here, the 1/2, square root of 2 over 2, square root of 0 over 2, 1. You just reverse the sine column to get cosine. And so they said this morning, you mean, so sine and cosine of 45 degrees are the same value? Yeah. Sine of 45, cosine of 45 are the same number. Okay, now, tangents are a little trickier to get. And the best way I can show you how to get tangent is to come over here to stick your rock crazy xylophone. Tangent is y over x. We've already got sine and cosine figured out. So where could I get y and x looking at sine and cosine? Look at the numerators. You take the numerator off of sine and cosine and you'll get tangent. So So here, yes, you would take 0 over 1, which is 0. That one didn't show it very well. What are the numerators of the 30-degree line? 1 over square root of 3, which they will rationalize. It'll become square root of 3 over 3 when they rationalize it. Okay. 45 is interesting because you get square root of 2 divided by itself, which is 1, yeah. Anything divided by itself is 1. Square root of 3 over 1 is square root of 3. And then last but not least, yeah, I'm going to divide by 0. Anything divided by 0 is undefined. So, and actually, anytime you have an undefined value, usually, at least with trig functions, that means tangent actually shoots up an asymptote right there and goes off to infinity. So undefined oftentimes means it heads to infinity. And ta-da, you have your special angle table. Okay, you're going to have to fill in that table for me on that upcoming test.
Are you kidding me? No, all
Yep.
that stuff for 20 points.
Are you going to leave the sine, cosine, tangent?
I'll leave the sine, cosine, tangent. I think I leave the 0, 30, 40 by 60, 90 for you too. So if you know the pattern, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, you can figure it out. Plus, you're going to use these for 2 solid assignments. You're going to get to know these real well. Now, if you may have seen my pre-calc people, like back in January with flashcards, yeah, I make them flashcards to prove me they know them in their heads.
So we have to know all that, the octet, equal baffles,
And that whole thing.
Yeah, that's why I say it's like 20 points of the test is just knowing stuff.
we get more like 40. You should make it like 30 or 40.
Or 80. No.
And make the test work like
But you didn't want a big point value test.
Yeah, but it's what's saving you.
All right, so if I said to you, quick, tell me the tangent of 60 degrees, you would say?
Square root of 3.
Tangent, 60 degrees. Boom, square root.
That's right.
Cosine of 30 degrees. Cosine of 30, cosine of 30 is square root of 3 over 2. Okay, it doesn't actually take long for you to know these. But, okay, here's the wrinkle, actually two. What if I said find me the secant of 60 degrees? Yeah. If I said find me secant of 60, you would go, oh, wait a minute. Secant is just cosine flipped over. So you would go find the cosine of 60 and flip it over, which would be 2. So you may want to, this is up to you, you may want to write up above that sine is paired with cosecant, cosine is secant. So if you want any of those three, you simply just find the value and flip it upside down. Okay, now, you're ahead of me, but you can hold that thought for a minute. 0 through 90 are in what quadrant? Those angles. Those are all first quadrant angles, but does every angle land in the first quadrant? We could make it that way. That would be boring.
That should be quite fun.
So you can do these values in other quadrants. You just have to know the secret. So suppose I said, let's find the, what would be great?
Cosine.
The tangent of 150 degrees. Okay. 150 is not there. How do you even know it's a special angle value? It's got anything to do with those 5 angles.
It's divisible by 30.
Actually, that somewhat is an argument, but that's not the real. What you need to do is you need to go, where's 150 degrees going to fall?
Quadrant. It's 3.
It's past 90, not to 180, it's over here somewhere. Okay, I know that angle is 150, but if you were going to draw the triangle, where would you draw the triangle?
Always down.
You would always go down. So therefore, it's this angle in here, that's the angle in the triangle, and how do you know it's 30? Yeah, 180 minus 150, that's a 30-degree angle. That's called your reference angle, because the tangent of 150 will be the same as the tangent of 30. So then you go to your chart and get the tangent of 30, which is square root of 3 over 3. Now, there's one other wrinkle, Blake. This is okay. He's worried about the positives and the negatives. How do you know whether that answer should be positive or negative? This is where I could be retiring on lost negative signs. You must look at all-star trig class. Tangent, second quadrant, is it positive or negative?
Negative.
It's not listed there, so it's negative. So therefore, this should be a negative square root of 3. You got to check the quadrant. So you look alive.
That part confuses me.
No, never.
So if they're not pluses, then they're not.
If they're not listed here, they're negative. This is always where they're positive. So let me see if you all can try one now here. Suppose I said, let's do the secant of 225 degrees. Secant of 225. You would go, first of all, where's 225? First, second, third. Okay, now this is the quadrant that's different. If I go up then, 225 was this line down here. This line is 180. So how many degrees are going to fall between 225 and 180? Subtract them. 45. Big hint. How many of those angles in that chart end in a 5? 1. If you're doing these, you know you're doing special angle values and you see a 5, it's a 45 degree angle. There's no other choice. If it's got a 5 on it, it's a 45. Okay, so I need the secant of 45. How do I get the secant of 45? I go get the cosine of 45, and I do what to it? And I flip it. Yes. So I would go 2 over square root of 2, which then you have to rationalize it. And so I have to go multiply by square root of 2. All over 2. The 2's will cancel then. It's a square root of 2. Now, that's a handy other trick to know about this. You flip over square root of 2 over 2, you'll get square root of 2. So what happens when you flip over this square root of 3 over 3? It'll be a square root of 3. So that's a little short. Okay, what have I not done that's going to cost me a half a point? Secant. We were in the third quadrant. Secant in the third quadrant is negative. So you have to do a negative square root of 2. What now? Okay. All right, I need to do 2 other things here, and I'm going to run out of space.
We're going to run out of time if you don't hurry.
All right, what if I said to you, find me the tangent of 180 degrees? How do you do it when it's on a quadrant line? It's not out in the quadrant, it's on a line. Okay. You got 180's over here. It's on the same line as which other angle? It's on the same line as 0. So if you're doing a 180, it's the same thing as doing the tangent of 0. So what's the tangent of 0? 0. Now, as far as positives and negatives go, since we were on the negative side of the axis, that technically would be negative, but since it's a 0, it doesn't matter. If I had you do sine of 270, you would go, oh, 270 is straight down here. It's on the same line as what? It's the same as a 90. Sine of 90 is 1, but because you're on the bottom side of the axis, that would be a negative 1. Okay, so
Can it ever be negative on the 180?
yes. Cosine of 180, because cosine has a value of 1, cosine of 180 when it's on that side then will be negative 1 because it's on the left side. Okay. Last thing. You're only doing the front side of that worksheet. The top part of the worksheet is what I just did right there. But if you look at the bottom 3 problems, I need to ask you, what does it mean if they write sine with a little square on it, 30 degrees?
You have to factor it.
What?
Square it. That'd be cool.
Okay, this is mathematicians basically being lazy. It means they didn't want to take time to write parentheses. It means take the sine of 30 degrees and square it. So you would go, oh, sine of 30 degrees is a half, and you would then square the number. After you figure out the number, then you square it. So that would be 1/4. So figure out the number and square it. What's it mean when they just have two numbers written side by side? Yeah, it's multiplication. So you find each number and you multiply it. And you would just multiply them together then if they're written side by side.
That's all you have to do?
Well, I'm that those because I picked 45 and 30, which are just straight out of the chart. If I had picked 135, then you'd have to go, oh, second quadrant, come down, 45-degree angle. Sine of 45 is square root 2 over 2. In the second quadrant, it's positive. I guess I'm not, we don't get out to 31. I think we got up to 27, so I got 5 minutes. So, let's work one of those.